Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on special theory of relativity. Lecture number 1, in which I will describe about the Lorentz transformation equations. Before describing the Lorentz transformation, I would like to give you the idea of postulates of special theory of relativity. Postulates 1. The natural laws must preserve their forms relative to all observers in a state of relative uniform motion. This is number 1. Number 2. The velocity of light in vacuum is independent of velocity of observer or velocity of the source. That is, the velocity of light is an absolute constant independent of motion of the reference system. The velocity of light is an upper limit of the velocity of a particle with which a particle can move in nature. So, it is impossible to send out signals with a velocity greater than that of light. These are two postulates of special theory of relativity. All the results of special theory of relativity are derived with the help of these two postulates. Now, I will describe about the Lorentz transformation equations. Let us consider S and S prime be two inertial frame of reference in rectangular Cartesian system of coordinates such that the axes x prime, y prime, z prime are parallel to axes x, y and z. Let the reference frame S prime is moving with uniform velocity v along x prime axis relative to the frame of reference S. Here frame of reference S is assumed to be fixed. Let observer of two systems are situated at the origin O and O prime respectively. Let time in two systems be counted by symbols small t and small t prime respectively. In S frame of reference, the time is counted by the symbol t, and in S prime system of coordinates, the time is counted by the symbol t prime. The origin of two systems coincide at t equal to 0 and t prime equal to 0. That is, initially the origins of two systems coincide. Let both observers are observing the same event at the point P, whose coordinates are x, y, z, t in S frame of reference and x prime, y prime, z prime, t prime in S prime system of coordinates, that is S prime system. Points which are in rest with respect to S prime will move in velocity v, because this S prime reference frame is moving with velocity v with respect to S frame of reference. So, any particle which moves with velocity v with respect to S frame of reference will be at rest in S prime frame of reference. That velocity must be uniform Otherwise it is not possible. Since this S prime frame of reference moves with uniform velocity v along x-axis. So with this movement of S prime frame of reference, origin O prime is also moving with uniform velocity along x-axis. So after time t, the origin O prime will reach at a distance x equal to vt. But still the x coordinate of the origin O prime with reference to S prime frame of reference will be 0, since the coordinates of the point P is x, y, z, t. T is a time coordinate. Therefore, x coordinate of P is x, and actually OA equal to x, and O prime A equal to x prime in S prime system of coordinates or frame of reference. And since S prime moves with velocity, uniform velocity v along x-axis, so after time t it moves the distance vt. Therefore O prime will be equal to vt here. Since OA equal to O prime plus O prime A, and O prime equal to Vt, and O prime A equal to x prime, and OA equal to x, implies that x prime equal to x minus Vt. But with consideration of special theory of relativity, let x prime equal to something alpha multiply x minus Vt, where alpha is the some function of v, uniform velocity v. Since the velocity of S prime is only along x-axis, so by symmetry y prime equal to y and z prime equal to z. This is number 1, this is number 2. Now we consider on the time. T prime be the time with reference to the frame of reference S prime, and this time will depend on time with reference to S and coordinates x, y, z with reference to the reference frame S. Linearly, it depends linearly, that is T prime depends linearly on time t, coordinates x, y, z. For the region of symmetry, we assume that T prime does not depend upon y and z. Therefore, we may express T prime as a linear combination of time t and coordinate x only. That is T prime equal to beta t plus gamma x. This is number 3, where beta and gamma are functions of velocity v only. Let us assume that at time t equal to 0, a spherical wave of light signal leaves O, which coincide with O prime at that moment. Since according to the second postulate of special theory of relativity, the velocity of light in both systems is same, and so the speed of propagation is same in all directions and equal to c in both systems. Let after time t the signal reaches at a point whose coordinates be x, y, z, t in S system, and x prime, y prime, z prime, t prime in S prime system. Therefore, after time t, the distance covered by the light signal is calculated in both systems as follows. In S system, the origin be 0, 0, 0. Therefore, distance formula will be x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square, and distance covered, the velocity is c. In time t, the distance will be ct. Right side c square t square, distance square. And in S prime system of coordinates, this will be x prime minus 0, origin of S prime system will be also 0, 0, 0. So this will be x prime minus 0 whole square plus y prime minus 0 whole square plus z prime minus 0 whole square, and the distance will be calculated with velocity c, which is absolute. Light signal, velocity of light signal is absolute. So the velocity of the light in this system will also be c, and time will be t prime. So the distance will be c t prime. So distance square equal to c square t prime square. And we may write these two equations as equation 4 and 5. Using 1, 2 and 3 in 5. In 5 we put the value of x prime from 1 and y prime from 2 and z prime from 3. And also we put the value of t prime. So here we write x prime is square equal to this whole square, y prime is y, z prime is z, and c square t prime is beta t plus gamma x, and here is square, here also is square. And rearranging we get the equation 6. Comparing the corresponding coefficients of 6 and 4. Here coefficient of x square is 1, and here coefficient of x square is alpha square minus c square gamma square. Therefore, alpha square minus c square gamma square equal to 1. This is equation 7. Coefficient of y square equal to 1, coefficient of z square equal to 1 in both equations, and coefficient of 2xt in this equation is alpha square v plus c square beta gamma, and in 4 this coefficient is 0. Here we do not get any term 2xt, so this will be 0. This is equation 8. And coefficient of t square is c square beta square minus alpha square v square in this equation 6, and equation 4 the coefficient of t square equal to c square. So this will be equal to c square. This is 9. Multiplying 7 by v and then subtracting 8, we get this value, and by rearranging we get this equation 10. Multiplying 7 by v square and then adding with 9, and we get this value, and by rearranging we get equation 11. Multiplying 10 by v and then adding with 11, we get this. This means this equation 12. Taking the value of gamma equal to here minus beta square minus 1 by v beta from 12, and now we put this in equation 10. Here gamma square, and we may write minus whole square, this is positive, here beta square minus 1 by v beta whole square, and here gamma, here also gamma minus beta square by v. and beta beta cancel and beta beta cancel, so remains this. And by calculating we get this equation, this equation, this equation, and ultimately we get beta square equal to c square by c square minus v square. This is equation number 13. Using 13 in 9, here in 13 we get value of beta square. So put here, we put value of beta square equal to c square by c square minus v square, and we get this equation, and ultimately we get alpha square equal to c square by c square minus v square, which is same as beta square. So we get alpha square equal to beta square, which is equal to c square by c square minus v square. This is equation 14. Taking the values of alpha and beta from 14 and using in 9, we get gamma equal to minus alpha square v by c square beta, and this will be equal to minus here alpha equal to beta, so 1 alpha cancel, this equal to minus alpha v by c square. We may write beta in place of alpha since alpha equal to beta. So this equal to minus beta v by c square. This is 15. Therefore, using values of alpha, beta and gamma taking from 14, 15, then using in 3, we get t prime equal to beta t plus gamma x equal to beta t plus means here gamma equal to minus beta v by c square. So we write this, and x, and we take common beta under bracket t minus vx by c square. This is number 16. Therefore 1, 2, 3 will be of the form. In 1 we get x prime equal to beta x minus bt. In 2 y prime equal to y, z prime equal to z. In 3 t prime equal to beta t minus vx by c square, where beta equal to 1 by square root 1 minus v square by c square. Here we may write this as 1 by alpha square equal to c square minus v square by c square, and this will be equal to 1 minus v square by c square, and implies that 1 by alpha equal to square root 1 minus v square by c square, implies that alpha equal to 1 by square root 1 minus v square by c square, and this is beta. So value of beta will be 1 by square root 1 minus v square by c square. Therefore, the Lorentz transformation equations are x prime equal to beta x minus vt, y prime equal to y, z prime equal to z, and t prime equal to beta t minus vx by c square, where beta equal to 1 by square root 1 minus v square by c square. Now we have a very important note. If v is much less than c, velocity of light, then v by c tends to 0, implies that beta tends to 1. Here v by c equal to 0, that means here remains only 1, therefore beta equal to 1. In this case, here if we put beta equal to 1 and beta equal to 1 and v by c equal to 0, that means x prime equal to x minus vt, y prime equal to y, z prime equal to z, and t prime equal to t. These are Galilean transformations. Therefore, Lorentz transformations reduce to Galilean transformation if the velocity v uniform velocity v is much less than velocity of light c. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.